Welcome back to the channel. If you're new here, it's great to have you. This is where we turn Python codes into real-world projects you can actually use. Today, we're diving into one of the coolest Python libraries for working with text, SpaCy. If you have ever wondered how apps process human languages, like chatbots, content summarizers, or tools that pull names and places from news articles, this is the tool you will need in your toolkit. Today, we'll cover what SpaCy is, how to install SpaCy, downloading a language model, processing text using SpaCy, tokenizing text, getting parts of speech tags, performing named entity recognition, NER, and explaining every single line as we go. If you enjoy this kind of hands-on practical content, please smash that like button and subscribe for more project-based Python tutorials. Let's build stuff together. Alright, what is SpaCy? Before we get our hands on the keyboard, let's clear up what exactly SpaCy is and why it's such a big deal in the world of Python text processing. In simple terms, SpaCy is a super fast, industrial-strength natural language processing library for Python. But what does that mean in practice? Natural language processing is a branch of artificial intelligence that focuses on helping computers understand, interact, and generate human language. Think about applications like voice assistants, search engines, chatbots, recommendation systems, or even grammar checker. Behind the scenes, they rely heavily on natural language processing to work their magic. Now, among the many Python libraries out there for natural language processing, SpaCy is known for being one of the fastest, most reliable, and production-ready options out there. It's used by companies and researchers around the world because it strikes a great balance between power and ease of use. Why do developers love SpaCy? It's blazing fast and built for real-world applications. It handles complex text processing tasks like tokenization, parts of speech tagging, name entity recognition, and dependency parsing right out of the box. It comes with pre-trained language models that you can use immediately, and you can also train your own if you need to. The API is clean, intuitive, and feels very Pythonic, meaning it works the way you had expected it to as a Python developer. So whether you want to build a chatbot, extract data from documents, analyze social media comments, or clean up large chunks of text for a machine learning project, SpaCy has you covered. In this tutorial, we're going to see how SpaCy helps us break down, analyze, and work with text data efficiently. You don't need a PhD in linguistics or AI to get started. Enough theory. Let's jump into some code and see this in action. I'll be using VS Code for this tutorial, but feel free to use any IDE you're comfortable with. It could be PyCharm, Jupyter Notebook, or even the good old Python shell. Now that we know what SpaCy is, let's get it onto our system so we can start playing with it. If you're using VS Code, like I am in this tutorial, open your terminal windows. If you're using a different IDE like PyCharm or Jupyter Notebook, no worries, it works the same way. Just open your terminal or command line interface. Now type this command and hit enter. Pip is Python's package installer. Think of it like an app store for Python libraries. Whenever you need to install external tools or packages that aren't built into Python by default, pip is your go-to. Install is a command telling pip what you want to do. In this case, we're telling it to install a library. SpaCy is the name of the package we want to download and install. When this command runs, pip reaches out to Python package index, which is like a big public library of Python packages, finds the SpaCy package, downloads it, and installs it into your Python environment. Once this is complete without any errors, it means SpaCy is now available in your environment and ready for us to import and use in our code. If you're using a virtual environment for your project, make sure it's activated before running the install command. If you're not sure of what that is, no stress. We've covered that in our earlier tutorials. Alright, let's move on and download one of SpaCy's language models so we can start processing some text. Here is an important thing to know. SpaCy doesn't work entirely on its own. Think of SpaCy as an engine of a car. The engine is great, but without fuel, it's not going anywhere. In this case, the fuel is a language model, a set of pre-trained data that teaches SpaCy how to read, understand, and make sense of text in a specific language. These models are trained on large text datasets and comes packed with linguistic informations like word types, sentence structure, name entities, and more. And good news, SpaCy makes it super easy to download and start using these models. For this tutorial, we'll grab a small but capable English model called en_core_web_sm. It's lightweight, downloads quickly, and has everything we need for basic text processing like tokenization, part of speech tagging, and name entity recognition. Let's enter the following code in our terminal. This tells Python to run SpaCy as a model. The -m flag is a way of saying, hey Python, execute this installed package as a script or program. While the download en_core_web_sm is a command we are passing to SpaCy, telling it to download a specific language model. Here, EN stands for English. Core means it's a general purpose model. Web indicates it was trained on web content, which makes it good for handling modern, messy text like social media and articles. SM means small, is a lightweight version, perfect for learning and quick demos without heavy resources usage. Once you hit enter, it fetches the model from the internet, installs it into our SpaCy directory, and makes it ready for use in our Python projects. If everything is installed correctly, you should see a message like download and installation successful in your terminal. And with that, we've officially geared up our SpaCy setup. Now, let's jump into some actual code and see this in action. Now that we've got SpaCy installed and our language model downloaded, it's time to start writing some actual Python code. So go ahead and create a new file in your Python directory. Let's name it SpaCy_intro.py. At the very top of our new Python file, type the following. Here, import is a Python keyword that tells our script to bring in an external library or module so we can use its functions and tools. In this case, we're importing SpaCy, the powerful natural language processing library we just installed. SpaCy is the name of the library we installed earlier via pip. Once this line runs, your Python script has access to all the cool things SpaCy can do, like loading language models, processing text, and analyzing sentences. It's kind of like adding a new set of tools to your toolbox. Without this line, Python won't know what SpaCy is, and any attempt to use these functions would result in an error. It's a good habit to place the import statement at the very top of your Python files. It keeps things organized and makes it clear which libraries your project depends on. Alright, with SpaCy now imported into our script, we are ready to start loading our language model and processing some text. We've got our SpaCy installed, we've downloaded our language model, and we've imported SpaCy into our Python script. Now it's time to load that language model into our program so we can start working with text. Here's how you do it. The SpaCy.load function loads a language model into our program's memory so it's ready to use. Think of it like starting your car. You can't drive until the engine is running. This line essentially turns the key and gets SpaCy language model ready to process tests. This is the exact name of the language model we downloaded earlier. It tells SpaCy.load function which model to load. In this case, EN English, core_web, trained on web content, SN small version. If you downloaded a different model like en_core_web_md for medium or en_core_web_lg for large, you had replaced the string inside SpaCy.load with that model's name. Please note, you can name this variable anything you like. NLP is just a common convention used in the SpaCy community because it stands for natural language processing. Alright, our model is loaded, our engine is running, and we are ready to start processing text. Let's put it to work in the next step. Time for some action. Now that we've loaded our language model, let's see how SpaCy processes actual text. Enter the following code. This line creates a string variable called text, and inside it, we've placed a simple sentence. You can swap this out with any text you like, a news headline, a tweet, or even your favorite movie quote. For now, we'll use this example because it contains a company name and a country name, which SpaCy can recognize as name entities. Here is where the magic happens. We are passing our text string into the NLP objects, Remember, that's our loaded SpaCy language model. Here, the NLP function takes the raw text, it runs it through the language model we loaded, and then returns a doc object, which is a special SpaCy container packed with all kinds of useful linguistic information about the text. Think of the doc object like a neatly organized folder. Inside, you find individual words and punctuation marks called tokens, information about parts of speech for each word, like nouns, verbs, etc. Details about entities in the text, like company names, countries, dates, and much more, all ready for you to explore. So now our text is processed and packed into this doc object. Time to start breaking down our text into its smaller parts. This process is called tokenization. In simple terms, tokenization means splitting up text into individual pieces, like words, punctuation marks, symbols, or numbers. Each of these pieces is called a token. SpaCy is really good at this, and it does it fast. Here is a quick loop to print out every token in our processed text. The for loop goes through each token inside our doc object one by one. Remember when we ran this line of code earlier, SpaCy processed our sentence and broke it down into tokens behind the scene. Now we're iterating over them. Now for each token in the loop, we are printing its .text attributes. This gives us the actual word, number, punctuation mark, or symbol as it appears in the original text. If you run this script, your output will look like this, with each word and quotation mark appearing neatly on its own line. Tokenization is one of the very first steps in text processing. Once your text is broken down like this, you can check for specific words, count how often words appear, clean up unnecessary tokens like punctuations, perform deeper text analysis like parts of speech tagging or name entity recognition, and a whole lot more, which we will explore in a bit. Now that we split our text into tokens, let's dig a little deeper and see what role each word plays in the sentence. This is called parts of speech tagging. It's how SpaCy labels each word as a noun, verb, adjective, proper noun, and so on. Enter the following code. This, just like before, we are looping through each token in the doc object. This line prints two things: token.text, the actual word or punctuation mark from our text, token.pos underscore, the parts of speech for that token. SpaCy uses standard POS tags like noun, a common noun, PROPN, a proper noun like a name or place, verb, a verb, ADP, a preposition like in, on, at, etc., DET, a determiner, and many others. This is string formatting using the F string. Here we are left aligning the text within a space that's 15 characters wide. This keeps everything neatly lined up when printed, so your words and their parts of speech appear in tidy columns. Running this, your output should look something like this. Pretty cool, right? You can already see how SpaCy understands language structure here. It knows apple is a proper noun, buying is a verb, and in is a preposition. Why is this useful? POS tagging is essential for many natural language processing tasks. For example, you might want to extract all the nouns from a text, find where actions occur in a sentence, ignore punctuation or determiners when analyzing content, build rules for text classification or summarization based on word rules. And the great thing is, SpaCy does all this for you out of the box. Now we're getting into the fun stuff. Named entity recognition, NAR, is one of SpaCy's standout features. It allows SpaCy to automatically identify and classify real-world objects in text, such as organizations like company names, places like countries, cities, or landmarks, dates and times, and even monetary values. With NAR, you don't have to manually search through text. SpaCy does the heavy lifting and finds these entities for you. Let's give it a try. This is a loop just like before, but this time, instead of looping through tokens, we are looping through the entities SpaCy has detected in the text. The doc.ent's is a special property that returns a list of all the named entities that SpaCy finds in the document. For each entity, we are printing the actual text of the entity, like the name of the company or a place, the label or category of this entity, which tells us what type of entity it is. Common labels include ORG for organization, GPE for geopolitical entities, dates for dates, money for monetary amounts, person for people's names, and several others. Run this and you should get output like this. In this case, Apple is detected as an organization. United Kingdom is detected as a geopolitical entity, meaning a country or place. Why is this cool? Any arrow is incredibly useful for many real-world applications, like identifying key entities in documents to categorize them automatically, pulling out company names, places, or dates from text for data analysis, automatically filtering out specific types of information like all location names from a large dataset, detecting location, dates, or company names from user input. SpaCy really shines with any error, but we are just scratching the surface. If you'd like to dive deeper into other cool things SpaCy can do, let me know in the comments. And there you have it, your first hands-on session with SpaCy. We installed the library, downloaded the language model, processed text, broke it into tokens, tabbed parts of speech, and pulled out named entities, all in a clean and readable way. If you enjoyed this tutorial and you would like to see more Python projects, practical text processing guides, and NLP applications, hit that subscribe button so you don't miss a thing. Drop a comment below letting me know what you would like to build with SpaCy, and I might cover it in future videos.